Well, as it turns out, it isn't as terrible as I thought. Um, we can see from this figure that we have a couple of right triangles here, and we can apply Pythagorean theorem to those two triangles. This triangle on the left, clearly we can see from that triangle that c squared equals r squared plus h squared. Now, this triangle over here, a squared equals h squared plus, well, what would this distance here be? That would be b, this entire length here, minus r. So the b minus r length squared. So that's h squared, and we expand this to get b squared minus 2br plus r squared. Well, so a squared equals this. Now notice I'll circle in blue. C squared equals r squared plus h squared. So r squared plus h squared, together those two guys make c squared. So that means that a squared equals b squared plus c squared minus 2br. And I will leave it to you. Well, it's pretty obvious that 2br is the 2 cosine of this angle, but I bet you can figure out why br equals, well, br equals bc times the cosine of a, which would mean that r equals c times the cosine of a, and well, I'm pretty much already there. R over c equals the cosine of a. You can see right there, r is the adjacent side, c is the hypotenuse. Adjacent over hypotenuse, that's the cosine of that angle, a. So I kind of went backwards. You have to say cosine a equals r over c, and then from there work this way. Well, actually, I guess I didn't go backwards. So I can just copy these guys. So this equals b squared plus c squared minus 2b times, basically from here, r equals c times the cosine of a. So you can plug in c times the cosine of a for that r right there, and you get the entire law of cosines. A squared equals b squared plus c squared minus 2bc times the cosine of angle A, because this is c times the cosine of angle A. Hope you followed that. And the other question about the two other forms, well, the two other forms would just be take, so c squared would equal a squared plus b squared minus 2. Just trade places, and oh, c squared would equal a squared plus b squared minus 2ab times the cosine of guess what angle? The angle that is between these two sides, cosine of angle C. So the two side lengths on the right side of the formula are the S and the S of the SAS. And the angle on the right side of the formula is the angle between those two sides. Hope you followed that.